Let's look at logical view of how CPU and RAM interact with each other and role of CU and ALU in CPU. Main memory or RAM stores instruction and data that will be executed. Control unit get the information from main memory, decoded and transferred to ALU. ALU execute the instruction and transfer to main memory to store it. This is the work of CPU that it fetch the data, decode it, execute it, and again store into memory. This picture also shows how a CPU works. In the last slide, we covered memory unit, CU, and ALU and how they interact with each other. But now here you can see more things like PC, SP, and IR. They all are registers. Now here is a question. What is the register? Register is a small high-speed storage space in the CPU that holds data needed for processing. Registers store data like instructions, addresses, data read from memory, data to be written to RAM, and calculation results. Let's understand the picture in a better way. Memory where instruction is stored, it is connected with the data bus and address bus. Data bus is used to send or receive data, and address bus has address of memory where data is stored. Data bus holds data that will be transferred to or from memory. Instruction register holds the instruction that is executing currently. Program counter holds the address of the next instruction to be executed. Stack pointer manages function calls and local variables. Control unit it directs the operation of the processor, telling the ALU what operation to perform. ALU performs mathematical and logical operations. Let's understand the work of CPU. PC sends the address of the next instruction to the MAR. MAR tell to memory for next instruction using address bus. Next instruction transfer to MBR and it's sent to IR for execution. The CU decodes the instruction in the IR to understand what operation is required. For executing, the CU directs the ALU to perform the operation. The ALU uses data from memory or register to perform calculation or logical operations. The result of the operation is stored back in the memory. CU controls data flow with the set ALU and status. The CPU continuously perform a cycle of fetching, decoding, executing, and storing the result. This is a simplified view of the connection between CPU and RAM. CPU and RAM interact via address bus A0 to A15 to access the address of memory location in RAM. Address lines send information to RAM which tell address from which data is to be read or where data is to be written. Number of total address lines determines the size of memory that can be addressed. With 16-bit address bus, the CPU can access to the power 16 different memory locations. Data lines D0 to D7 are used to transfer data between the CPU and RAM. When the CPU writes data to the RAM, it sends the data through these lines. When CPU reads data from RAM, it receives the data through these lines. RD and W are control lines that determine the direction of data transfer. When RD signal is active, it indicates that the CPU is reading data from RAM, or when the WR signal is active, it indicates that the CPU is writing data to the RAM. The coordination between address lines, data lines, and control signals ensure that the CPU can efficiently fetch instruction or data from the RAM or write the data to the RAM.